All right, so anybody in the live stream world who's listening, watching this, this is a typical, I don't know how typical, design review. Anyway, we're discussing new feature in Wolfram Language, which is integration of a SystemModeler systems engineering system. And let's get going here. So we're going to look at the preliminary documentation for what we're doing here. Let's see, what was the name of the guide page I'm supposed to look at?
System modeling overview.
Okay. That's interesting. This isn't working. Oh, here we go. So we're running, for those who are watching and care, we are running a preliminary test version that has this new materials in it. Okay, let's take a look here. All right, so let's start off. So I can't remember where we got to last time, but I think let's just enter some basic thing here. We've got here, make this a little bigger. We've got here a system model. So what do I do? What happens if I press plus here?
It shows you a little bit bigger diagram of the model.
This is a full-size diagram. Normally, those are full screen. You know, when you use the full system modeling tool, those are full graphical diagram-based modeling. Here, it shows you that diagram, but you don't want that in a list if you got many of them. So it has an abbreviated form.
Why are we using? I mean, we're still sticking in these diagrams with a pure blue, even though we've gone.
The color is significant. Color signifies domain. Blue is electrical domain.
Okay, so but the outer boundary of this image is also blue. Is that?
Yeah, that one we can change.
That one we can change.
We should change that. We should pick our. I mean, maybe we should have orange like a standard graphic. Or what is this thing?
No. It absolutely should not be standard graphic. That's important.
Okay. Well, so what is the model? What is the kind of theme for the system modeler stuff? Let me try another domain. Can I try a different domain? How do I go? So if I do system model examples, what will I see here? If I just say system model examples,
you can empty bracket, and it'll give you a choice.
And what's happening right now? Is it loading something?
It's creating this browsable interface.
Right. So in the initial period there, it wasn't showing any kind of loading indicator, and probably should.
Yes, it probably should.
And also, you're going to be part of the loading indicator standardization effort, right?
I'd like to.
You're supposed to be. I'm not sure who's coordinating that. Lexi would surely know who is PMing that. Okay, so here, what is this? This looks awfully big.
Go to normal size.
The colors, yeah, it's 125%, but the colors are not final. This is a brokenness of the system. These are usually colored. It's a
okay. So what is this? So this is like an inverted pendulum. So what happens if I press inverted pendulum? To get that, what happens if I copy paste this? Doesn't work.
That one,
how do I?
There is a copy paste button, the top right one of the 3 buttons.
Yeah. So I don't think that I mean, we have a somewhat standard copy paste button. Okay, that's what I get in the end. Why not just have that string?
Actually, I just changed that today, and you would get system model of that.
Okay. All right. So let's try. So let's say I get system model, and now what happens? So this, then, if I press that, I'll get this thing. Cool. This is nicely shrink wrapped, whereas this is not, but that's okay. So now if I want to simulate this, what do? Do I say system model simulate?
Yes.
Or system, well, let's do system model plot of that. Will that work?
Yes.
Let's try it.
Either works.
Yet another diverse.
No.
It's 2 different things. System model plot gives you a plot directly, while system model simulate gives you an actual object with data you can export.
No. I was complaining about the loading indicator.
Right.
So I agree. That's modeled on the net train thing,
yes.
Isn't it?
Yes. On the other one, you see on loading the start of the functionality models on the Packlet download indicator. And those are the only two.
So this is nice. By the way, why are the graphics the size they are? I mean, I don't object to this. I think this looks pretty good.
But
look,
this is a preliminary way to do grids, and it's gonna look better once we get support for paneled plots and.
Okay. All right. So let's try, just so I understand. If I want to extract, let's say I want to change the parameters of this pendulum. Let's say I actually just want that plot to be to extend for more time periods. How would I start to do that?
Then you'd have to run SystemModel simulate with an actual simulation time. So SystemModel simulate of your model.
Or plot.
Okay.
No, not
or the plot. No, I show you the
not
plot
of
is
the
just
plot.
graphics by this point.
Yes.
But you want the actual data? Fine, then simulate.
Yeah, exactly.
Okay, so let's do it. So I say simulate that, and then
Comma,
is there a single time variable?
Yes, either a list of start end time or just the end time. So you can say like 30, and then you get from 0 to 30.
And what units? If the thing had units, would those units be included there?
If the thing has units, it's gonna convert it to seconds and use that.
Okay, if I just give a raw number, it will convert to seconds.
Yes.
So were I to give seconds here, so if I were to say control equals 25 seconds, for example, then that would do something useful.
Yes, it would simulate between 0 and 25 seconds.
Cool. Okay, so when it says model inverted pendulum there, that model actually has more. There's more detail to the name of that model, which is not being shown there somehow.
Right. So this system model simulation data object has properties. One of those properties is model name, which will give you the full name.
Okay. Do you not want to have some UI here that you can click on to get the full name in this case?
Maybe. I think that's. I don't think it's.
You think it will be disambiguated by that most of the time?
Yeah.
Just by the summary name.
Yeah, I think that's going to be most of the time, and otherwise you can ask for it. I don't think it's going to be a common problem.
So let's say I want to get an interpolating function out. By the way, is this plot that wiggle there? Is that does that come from one of the variables here?
Yes, it automatically tries to choose an interesting variable to create the minimal diagram there.
Okay, and so that's a lot of variables. 724. Is that the total number of variables required in the internal? So how do I get? So if I get SystemModel there, and I want the equations, can I get the equations? So let's say I just do properties here. Actually, if I say property association, will it give me the whole ball of wax?
Actually, no. You can do association, but I wouldn't recommend it. Because
but so by the way, property association, I think, is the way that you should do that, because that's the general thing that we've done elsewhere.
It does have an association which gives you that, but it's going to be slow for large models because it calculates.
Did we go through these names?
Not all of them.
What are local components and local plot names and local plots?
So the models are hierarchical and can use the object-oriented extends, like what do you call it? When you inherit something, so you have base models and then you inherit stuff from that.
But so is this more the self model, or why does it say local? I mean, local seems like something different when we've got clouds and local and things like that.
Right. I mean, the property names can be discussed, but there's local components and components. So components flattens everything out. Actually, yeah, components.
Inherited components. Yeah.
Right. Yes.
So I don't think local is the right name. I mean, maybe it's self, maybe it's some. Okay, so there's a controller, a gear, a motor, a pendulum.
Right. This is a slightly old build. So in the newest build, the left-hand side of these elements would be strings, and the right-hand side would be new system model objects.
What system model objects? What?
Where you see here the LQ control system, for example, would be a system model of that thing. That's what it is.
That makes sense. Yeah. That makes sense. But what? And the left-hand side string is
Yes.
just the name of the thing in this local model.
Yes.
In this.
Exactly.
I don't really like the word local. Roger, can you think of a different word?
What do you mean by local, Malte? Do you mean like components that are developed just for this example?
No, I mean here all the I think all 5 are local components. It means they're declared exactly in this model. While if you build on partial models, you can inherit stuff into the model and not declare them locally. So then the local components are the ones declared exactly here in the inverted pendulum model. While if you inherit something else which has additional components, those are the inherited components, and the components are the union of those two.
Yeah. So this is the ones. I mean, you could call them model components. It's a little weird.
They're all
model
that.
name.
I mean, they're all that. So that's not.
Well, what is model name? Is model name the name of the complete?
Model name is just the string you have there. Introductory example systems inverted pendulum.
I wouldn't call that model name because usually when we use name, it's a human readable name. I think.
Right.
I mean that if it is a name.
We can call it model identifier.
That seems better to me. What do we call it in the case of an entity? The string that represents that is the internal piece of an entity. I don't think we have the right people here to answer that question, unless you know. But let me.
I don't have it. No, I don't know.
Okay.
Well, there's the entity type, but that's more the type.
No, the entity type is the first element. I mean, what I'm talking about the second element of the entity. I mean, it's usually called the standard name. And that's the, if I say standard, I wonder if we even have that. I don't even know if we have. If I say, oops, what just happened? Oops, that's a problem. My keyboard is not working. Humph. That's very odd. That's something new and different. Great. Okay. That's exciting. Let me see. I just failed earlier today, but why did it fail again? Let's try plugging and unplugging it again. No, it's working again. Very odd. Okay.
We have the canonical name of the entities.
Oh, that's what it's called? Canonical name?
I think so.
If I say canonical name NYC, for example, then it will say, yeah, there we go. So this is probably closer to canonical name, right?
Right. Yeah. It's very like canonical name in that it's a unique identifier for this specific thing.
But now the system model itself
but users,
is that correct?
Different users will create those, Stephen, so you understand. Those will be user created.
Yeah, that's okay, I think. Yeah. I'm not totally sorry. Look, let's make sure we cover what you wanted to cover in this meeting, because I'm just poking at things randomly here.
Right.
So what did you want to cover?
Right. So maybe we should go through the things we haven't covered before.
Fine, let's do it.
One is, let's see, if you go to
model creation. What's that? Go ahead.
If you go to model simulation, the top guide page link there. We've covered some of those. One of them, there's one new symbol since last time: SystemModel progress reporting.
What is an option?
It's an option for controlling how progress reporting happens.
So, Stephen, here's another place where we can generalize to have a generic. Right now, there's something called net train progress reporting. Okay.
That's horrifying. Yeah.
I think it could become a general progress reporting thing that we start supporting when.
Seems sensible to me. Yeah. I mean, what other places do we have? I mean, we also have. Don't we have a evaluation?
There will be some. There might be some unique things, but then you have to in other words, this is a general symbol, progress reporting, but not all functions may support the same kinds of things. There might be sort of restrictions and extensions. That's the problem.
I understand, but okay, well, hold on a second. So step monitor is something very much like this, right?
Except it's
a thing that you evaluate, but you have to tell it, go ahead and print something. Whereas what this is doing is this is proposing to do it automagically, so to speak, rather than to require you to actually have an explicit piece of code in there.
Yeah.
Exactly.
Right?
Yep.
So we can imagine any function that has a step monitor.
Step monitor was sort of the first generation of this, if you like. You know, where we provided such a mechanism.
Right. Well, I think this is perfectly sensible, but then I think we should be looking at what functions have step monitor, for example. And isn't there a nice way to do that using Wolfram Language data? I never remember how to do this, but there's a, let's see. Well, look, we can clearly find this, which functions have step monitor, but anything with a step monitor is a candidate to get a progress. I mean, so you're proposing, I think, the progress reporting arrow, and then potentially what we can do there is
have a few standard things that are very generic, but then some are going to want to go further, like NetTrain might want to go further. They have some other special things that only probably applies to NetTrain.
I think it's called training progress reporting.
Oh, training progress reporting.
Yeah, training progress reporting.
Okay, so you've copied this basic scheme here.
Some of them I don't support the function part.
Why?
Because it's harder and not as obviously useful at the first.
Okay. But I mean, but what it's doing in general, I would think the function is being applied to an association.
Yes.
Maybe.
Okay.
And the other issue here.
There are concepts here like batches may not make sense for everybody. You know,
no, absolutely
it's only
not.
when you have batches, and rounds may not make sense, but maybe, yeah, etc.
Well, I assume that this is using the units framework. I mean, so this is just I see. So there's a unit here. One could imagine something which is, I don't know, some geo function where it's, doing some physical, where it's looking some number of kilometers around some point or something, where the units here could be, I mean, but that's getting a little bit hicky. I mean, to me, it will be better. Is the reporting interval?
This one talks about time this talks about when, not where. Do you see what I'm saying?
Yes, but what do you want to talk about for system model progress reporting? Is it also time or not?
Yeah, it's time.
Yeah, we only need by time.
Simulation time, basically. I mean, it could also be, you could imagine a situation in which it's simulation, in which there are many components in a system and you're reporting which component you're looking at the updating of or something like that.
I don't think that's going to be useful.
Not for the way that this is structured in the way right now.
No.
Okay,
but you might want simulation time or real time. You might want to update every 2 seconds.
Yes.
Or you might want to update every time it goes 1 second simulation time.
Or you might want to update, in a more exotic case with the pendulum, you might want to update it every swing of the pendulum, which is more difficult.
That's more difficult, yeah.
But I mean, is there a natural time, time constant in a bunch of the models?
No.
No.
Okay, well, so look, just for this, let's just think about this for a second. So, I mean, progress reporting is, first thing is, that there are various different aspects of this. There's the how to report, i.e. panel, print, etc. You could imagine a situation where you want it to send you a text message. I mean, if it's a slow, reporting thing. So how to report. Then the next issue is what to report.
Which partially overlaps, I guess, or it could.
Partially. Yeah, I mean, there could be a lot of choices. And then there's when to report.
Right.
So here, let me just save this someplace. Where am I saving these? Do I have a SystemModel ILD folder? Do you know?
I think so.
SystemModel, yep. Okay, great. Okay. All right. So then, now this is analogous to if you look at Document Generator, it has all kinds of notification options, right? Actually, it has a general thing called a notification function. Okay, so that which has a function applied to a certain oh no, that's should be sent from background tasks. Okay, so that's a model, a partial model, in the sense that what is going to happen. So the what to report might be apply. I mean, so one way to think about it is this thing here, the how to report part. Here, let me make these. How to report is basically function to apply to some structure, because that would be a function that says, maybe panel doesn't work quite like that, but what to report would have an association.
I mean, panel might be a special case where we provide the function that's applied.
Well, yes, but it's a little bit of a weird. I mean, but yes, that's right. But I would say that, you know what? Let's break this into how to deliver the report and how to format the report. What to report, when to report. So, I mean, to me, this is beginning to look like progress reporting goes to, and then it ends up being an association that, I mean, it might be that you can have a default that just says panel or something, but in general, the delivery method or something, or delivery function might be something here, followed by formatting, format, followed by, well, is it interval? I think that's what we were calling it elsewhere. Reporting interval or something.
Yeah.
And then we've also got this notion of what to report. So contents, maybe that's contents, which would be potentially a list of string quantities that are capable of being reported on, so to speak. So let's see how this maps onto what we have for training. What is it called? Training progress reporting?
Yes.
Okay. Oh, I see. That's just showing a progress indicator. That's a slightly complicated thing, because that will just be something that has to know, you know, what does 100% mean? Look, I think we should have a separate meeting to discuss these progress indicators and try and
think
merge
so
them.
too.
But I think this is the basic direction that I think we should be going in. It's some kind of association with attributes of the thing, but it needs to make sure that it is merged properly with the way that these notification functions work for things like document generators and
can you take that, Stephen? Because I think you need to trigger it.
Yeah. Okay. Fine. I will.
And so then we fork that off, and you know, here's another place where it's ripe for it. Okay.
Okay. All right. I'm just sending mail here. Okay. Let's go back to your agenda here.
Okay. Then I'd suggest we look at how we handle equations.
Okay. Oh yeah, and the formal variables of equations. Okay.
Right.
Go ahead. So let's look at the equations for this guy here. They're probably pretty complicated, right?
Yes.
So let me look here. So if I go here, how do I get the equations?
It's a system equations property.
going to take forever to format it. How complicated are they? How complicated can an inverted pendulum be?
There were 700 equations. So
how can there be 700 equations for an inverted pendulum?
It has a control. It has
also a controller and stuff, and there is also some support for animation display of this.
Why does that have to be in the equation? Okay, look, first question, what are these errors?
These are the equation translation support is not 100% yet. So there are constructs in this model that we can translate into Wolfram language.
Pack shape ampersand?
Right, so you're running a slightly old version of this, so that's not going to be there in the newest.
All right, okay. So what are the questions here? So these formal variables, which I'm not a big fan of. Now we had a separate discussion about.
One thing, Stephen, that makes these equations become bigger is to support flexible modeling. That means that if you connect two components, you basically get simple equations that says A equals B. The wires that connect them up. So there are trivial equations. Some of those can be eliminated. But then you won't know what those variables are if you need to know their value, for instance, for analysis purposes.
I see. So in other words, there is a wire which has one end is an A and the other end is a B, and so the presence of a wire means that there is an equation A equals B.
Yes.
But you can eliminate the wire equation, but then you don't actually know then there is no variable that represents what's on the wire.
Right.
Is that correct?
So simulation does that, and it sort of bookkeeps those things. It knows how to reproduce them. So it does eliminate them, but then, the bookkeeping, so you won't lose anything. Do you know what I'm saying? But if you actually want equations and analyze equations, you need to deal with them all.
Okay, so hold on a second. So what you're saying is when you say there's 729 equations for the inverted pendulum, that includes these wire equations, basically.
Yes.
Wire consistency equations.
Yeah.
And so how many would there be roughly in this case if you didn't include the wire consistency equations?
Let me check. But I think it drastically reduces it.
Let's get a sense of how much, because then what you're asking is, maybe there's a property. I assume these properties are computed on demand. These properties are not pre-computed. Is that true?
Right.
Yes.
So then are you asking we need two properties, one that is the full system equations and one of which is the eliminated system equations or something?
We actually have that. If you add after the system equations, add a comma, method goes to elimination as a string, goes to all. I think that's it.
This is still getting pretty big. Something's taking a while here. So give me a sense. I mean, some of these other models that we have that are, the higher end models, are we looking at hundreds of thousands of equations?
Yeah, in the worst case. Yeah.
So they went down to 180.
Okay, so it went from 729 to 180.
Yeah.
What on earth is test discrete changes?
It's an internal when event and this whole thing we need for a certain construct.
Okay, so how would I get a more global sense of what's here? I mean, first of all, these names are incredibly long. Can I get these equations summarized in some way?
Not really.
How would I change every one of those things into, I mean, if I just wanted the skeleton of these equations, so how would I change? Is there a substitution I can make that just changes every one of these boxed objects into something? What's the head of those boxed objects?
That's one of the parts that we have actually changed in the newest builds. Those are quantity variables.
Okay, but what are these right here? Just so I can try it right
those
now.
are dot name and then comma separated strings or arguments for one. Each part of.
So if I just said here on line 16, I said, and then I say dot name of triple blank goes to, and then let's just say, I'm just going to make up something. Let's say, I don't know, green or something. It's just going to be a blob, right? Are those equations going to? No, you know what? I'm going to have to put in a unique variable, aren't I? That's really kind of horrifying. Or are they? Well, let's just try it. Let's just try making those all into green blobs, and it's probably going to do something pretty stupid.
Right.
Okay, so this gives us a sense of what the shape of this creature is. Well, actually, it doesn't give us much sense at all. How can we get a sense? Is there some graphic visualization that will just show us roughly what's going on with all these equations? I mean, probably it will help if I just make those into a column, for example.
Yeah.
Actually, if I do a multi-column, I don't even know how this works, but multi-column there. Let's just use our. Okay, that's the number of columns. So let's say if I do 4 columns, for example. Come on, why is it taking forever? What is it doing? Okay, this is pretty hard to understand.
Yeah, I mean, some of the equations became green equals green, so.
No, I understand that. So that will fail. But I mean, these things here are still, this is deeply incomprehensible. What's going on here? So maybe you had a question about these equations. I mean, my question would be, how do we illustrate? How do we give some kind of summary of these equations? Or is that just not possible? I mean, is the summary of the equations basically the picture of the components?
Right. I mean, an easier way to get the sense of a model is to explore the components rather than going directly for the equations.
Right.
I think.
Yeah, but I mean,
I think equations are very powerful. So that's the foundation of Modelica and SystemModeler, but they are super large scale systems of equations.
So you're basically saying equations are the assembly code of modeling.
Yes,
Yeah,
exactly.
Okay,
actually,
fine.
That's very funny. That's exactly what we used to say. Several people that have designed higher end modeling language, they view equations as assembly.
Yeah, especially when you look at them at this scale, when you sum up all the equations for a model.
Okay, so nobody wants to look at assembly code, so we just shouldn't worry about it. So what's your question about the equations?
No, I just wanted to point out that we have solved this dot name thing and replaced them with the use of quantity variable.
That's good.
Is basically the result of this whole named object meeting series we had. We realized.
That's good. Can I see what those look like? Do you want to share your screen and show me what those look like?
Or can
I? Okay, go ahead.
So let me, So I chose a slightly simpler circuit, an electrical one. So this is an electrical circuit.
Okay, but the basic point is that we are formatting the those things with. Can you mouse over one? Quantity variable electric current. That's
yeah. So they
is that? The name is that weird string with dots in it.
Yes.
Right.
So if you look at
if
you look at the input form here, you see that it's quantity variable, the string with dots in it.
Yeah, that's pretty nice. That seems perfectly reasonable. A question about the display up there. Do we actually want to use dots, like periods like that, or do we want to do something more stylized?
I don't have a strong opinion. The dot has the thing going for it that it maps into
what you type in.
Yeah.
All right. Okay. I mean, this is pretty ugly stuff, but I guess that's just life. Okay.
Yeah,
looks
and
nice.
as we said, you don't usually look at the equations in this at this scale.
Okay.
If you look at equations, you look at them for a specific component usually.
Yeah, at small scale, equations are great. At large scale, I mean, they are too, but you need power tools.
Yeah, right. Okay, so let's keep going. That all looks good. So did we look at, what is parametric function? That was a thing we've discussed before, right?
Parametric function is, parametric end solve generates parametric function, which means that you can regenerate quickly a solution you can differentiate with respect to the parameters. So the differential, what's called sensitivity, when you differentiate the differential equation solution with respect to parameters. That makes it super,
so if I say,
makes it super efficient.
Yeah. So let's try this, for example. Let's say we've got the system model here thing of the inverted pendulum. Okay, and now we say I want to make a parametric. What just happened here?
Don't
My
know.
gosh, what just happened?
It
It crashed. Okay.
Yeah, some of the dynamic stuff and the expand collapse is not fully final and stable yet.
Okay, but anyway, so when in order to figure out that parametric, whatever it was, okay, no models are available to browse. Why is it saying that?
If you reevaluate it, it will come up again. It hasn't loaded the system modeling functionality, and it doesn't do that on startup.
Okay, all right. So let's okay, let me just close these up. I think these were, wow, they've been taking it a long time. Oh, don't say my keyboard's failed again. Oh, there we go. Okay, so now what I was trying to do was some parametric version of this. Okay, so I'm going to put that down, that system model there. Okay, I can unwrap it. By the way, do you have the predictive interface doing sensible things with these?
Not yet. We want to have the final design first, so we get the right.
Okay, all right, fine. And what are you going to do with autocomplete for things like the innards of a system model?
There is already, or maybe not in your build, but in my build there is autocomplete for many cases.
Okay,
I'm working on getting it in all the possible places.
Okay, fine. So let's.
We had that already before. We just want to make sure that it's filled up every place.
Yeah, we can have it more places now.
Great.
Okay, so let's take a look here. Okay, so I was going to try a parametric version of this, and then I want to talk about create system model and so on.
Sure.
And I don't know what does system model reliability do?
It's a niche thing where you can get reliability information about a model if you have encoded such information.
Reliability as in mean time between failure, or reliability as in was this model wrong?
No, as in mean time between failure, the statistics distribution measure.
It's cool. If what? If you put MTBF for individual components?
Yeah, you have to put you have to add on a per component basis reliability information, which is sort of natural, right? Because if you have two different pumps with different reliabilities, you need to provide different reliability information as the base. When you build up a big system, you synthesize all these things, and the reliability depends on how the system is put together. You know, can this pump fail and the system still work?
How do I get this parametric thing going?
There's the system model. Let's see, system model parametric simulate, which is a function you run on your system.
I understand, but system model parametric simulate has to have a bunch of parameters, right?
Yes.
Or can I just run it?
Maybe
will that work? Or
look at the page.
No, it needs more arguments.
That by the way, is really lame. That it doesn't have its syntax stuff in it. It should have a red caret at the end there.
Yes,
right?
It should.
Can you look at its page?
I'm trying, but that's okay.
I mean, in the source.
Oh, yeah. Okay. So it's got a lot of stuff here with variable v with parameters p.
Yes, it's slightly. So the variable v is what variable do you actually want out afterwards. So this is slightly more restrictive than the system model simulate. You actually have to choose which parameters you want to.
So is this supposed to be analogous to NDSolve, where you're giving the dependent variable first?
It's analogous to parametric NDSolve,
where you give the dependent variable.
Parametric NDSolve is like NDSolve, but it has a list of parameters last. You can say, you know, these are parameters you should keep track of. These are, you know, some constraints on them.
Okay, so here
So you recognize the beginnings is just like ND-solve, and then the parameters.
Why not? Okay, so those are the parameters there. So you've given a time interval there.
So in principle, with that A, you get that parametric function is an infinite collection of interpolating functions.
Yeah, I understand. But my question is, why, in terms of argument order, why is there no time variable in parametric?
It's optional because it's that information can be stored in the model. You can still give it if you look at the last two usage.
Okay. So those ones would give it between vars and the p sub I. Between the v sub I and the p sub I, you can insert a time. Is that correct?
Yes, that is correct.
It's a little funky, isn't it?
It's the same order that parametric can.
No, I know it's the same order. It's just the way that's dropping an argument is a little weird, but I guess it's okay. All right. So in this case, if I were to do this parametric system simulate, and I were to say, what's a variable here? What variable do I have to? Could I ask here for variables?
System variables.
Okay. By the way, that autocomplete should also work.
Yes.
Right? At the sub value.
Yes.
God, how many system variables are there?
700 something.
How can there be? Wait a minute.
It's the same model as before.
But that's the variables.
Those are variables.
Okay, so if I say motor resistor .n.v.
Resistor is typically not super interesting, right?
I mean, it might be.
Maybe it is.
Well, I'm going to say body cart body v underscore 0 of 3, whatever that might mean.
Right. That's the derivative of the velocity in the third dimension.
Okay. So I would give that as the variable. And what's an example of a parameter?
An example of a parameter would be pendulum. Let's see, what's an interesting.
Can I get it out from? Is it in the same system variables list, or is it a different thing?
No, it has a parameter names.
And how do I get the parameters out of the model?
Yeah, parameter names.
Okay, so if I said something like, what is controller.c? But let's just take motor EMF. There it is.
Yeah, that's probably a good one.
Okay, so then I give that there as the next argument there. Is that correct?
Yes, but in a list.
You shouldn't require a list. There's only one of it.
Maybe it works without a list. I'll make sure it works without a list in the future.
Okay. Splosh.
Right. It's probably you need strings instead of these dot names. All the other ones will return strings in new builds.
Okay, fine, but so okay, fair enough. Okay, fine. I get roughly what this is doing. Okay, so let's look back at the overview here. So what else do we need to make? Okay, create system model. What is that now?
You can build system models from some objects that are themselves natural system models, like state space.
Right. Yeah.
State space transfer functions. But you can also use differential equations, and you can, those are the things that this one support. And then there's a connect components where you wire up existing components.
Create data system model. What is that?
It takes various form of data and basically creates a single generator model.
Often
so
what you
like
need...
an interpolating model of some kind, a black box model of some kind.
Yeah.
So can we put a neural net? Can we put a neural net in there?
Not currently.
Should be able to, right?
This is just...
Why shouldn't we be able to put a net chain or something like that, or a net graph in there? Because it's that again is an input-output function. So if we can put an interpolating function, well, maybe
what we can't do now, but which we will do, is to be able to include Wolfram Language things inside of the model. That can't. But what you can do now is to feed it. See, I'm saying you still need environmental models. You might need a temperature around something. You might need road conditions or something. But if you want Wolfram Language statement in the middle of a model, we have to segment that off a little bit, because these things run very fast and they need to actually work in the same, it generates code, C++ code, right? So can we generate C++ code or make it run on a slower track where it can call back into Wolfram Language during the simulation?
So there are several things. So first of all, there might be an altitude or something, right?
Yeah.
And that will be called once, right? You're just, I mean, not if you're discussing an airplane, but I mean, if you're, let's say you've got a motor that's working at, is on the top of, Mount Everest.
So this one right now, Stephen, works perfectly fine for sort of passive data, time series, audio, interpolating functions, things that are like that. If it needs to dynamically execute, it needs to sort of be called from that C++ code.
Right. For which the compiler will ultimately be the solution to that.
Exactly. But also, there's another notion called synchronous, where you basically, in real-time systems, you don't sample every system at the same rate. And so there's a subsystem where you can control, if you want slower track, like that's how you design real-time systems. Not everything runs on the metal in a microcontroller at, thousands of hertz. Many things only run, 10 times a second. Do you know what I'm saying? The higher level, in these autonomous cars, most things run at a much slower rate than the on-the-metal controllers.
Okay, so what does that look like? So your point is?
My point is that I think that there's multiple levels. The things that need to run at the low-level model level, it needs to kind of basically compile all the way out and run at that speed. On the other hand,
are we in a position to output autonomous models? I mean, can we output the stuff for a flight controller or something?
Yeah, these things do generate code. It has its runtime, and people use it that way to plug it into other systems.
But so right now, that's a SystemModeler capability to be able to generate code. Is that correct?
Yes.
Yes.
And do we intend it to be a Wolfram Language capability or not?
Not at this time. I mean, it does sort of, but it's not in this set that we're explaining here.
Okay, fine, but I'm still trying to understand. By the way, I'm not keen on the term create system model, because usually what that means is when we use the word create, it means create something in the world, right? Rather than create something locally in the expression space, so to speak.
I mean, it's depending on how you look at it, it does create something in the world. If you also have
the same way as create document does.
Well, I mean, if you have the SystemModeler graphical environment as well, it will show up there as well, and you can save it to disk from there.
How does that work? I mean, so in other words,
they really share memory space. It's not, they share. They have a storage system that they share. It's persistent storage.
Okay. Well, that's a reason to call it that, I suppose.
Yeah, and then we have save system model, which allows you to save it to disk.
That's kind of funky. Why can't I just use, put? I mean, it's an expression, isn't it?
Not
what is
really.
Serialization of a system
model? No, it's a whole hierarchy of models. It's not an expression per se.
Okay, so hold on. This is one of these. We've got to make it work in some sensible way. So, part of the rule is that let's see. Part of the rule is that the thing you see must be serializable and outputable. So, what we've encountered that issue in a bunch of places recently where it's pointing to some weird raw Java object or something. And we've agreed what has to happen in that case is that there has to be, well, okay, so let's talk about what happens in this case. So if I take one of these things,
Save system model has simple... so one thing, let me just explain one tangle here, which is important to understand. So using libraries for a domain, like say electrical circuits or thermal systems or magnetic systems, that's great. It's a great time saver. It's, you can model at the right conceptual level. But when you save it, you might want those. It's a little bit like subsetting fonts in Adobe or something like that. You might not want the whole font. You only want the things that make this model run.
Yep.
Okay. So it will do the correct subsetting of fonts, if you like, the subsetting of models.
That's when you do the save of that model.
When you do that. That means it can work on its own without you having the whole of...
No, I understand. So it's only saving the dependencies it needs.
Exactly.
Okay, fine. But that's not my point. I mean, my point is that whatever you see here, if I were to save this notebook, okay, so let's be clear about one thing. If I save the notebook and reopen the notebook itself will contain enough information to recover the model. True or not true?
True.
Okay.
Well, not necessarily, no.
What do you mean?
If you save the model, you will get that model. If it uses other models, those will not be saved.
Okay, let's talk about that.
That's the same if you open any notebook that uses...
Yeah, right, and it uses something else. Okay, fair enough. Fair enough.
I mean, that happens.
And this is actually modeled, the save system model is modeled on save notebook.
There isn't a save notebook. Is there a save notebook? What does save notebook do?
Or maybe it's notebook save.
What does it do?
It saves
it will be notebook save.
Notebook
yeah,
save.
but that's different. Yeah. I mean,
it's the same thing.
Yeah, but that's just saving the file system. I mean, I don't understand why there's a save system model. Why I'm not just saying
file system.
Okay, but why is that not just put of this system model thing to a file? Why isn't it just that? Why does it need its own function?
If we wanted it to have that, we would have to implement a special down value for put anyway.
I understand that. Why would we have to do that? I don't understand. The thing is an expression, right? That first thing is an expression.
As you see there in your input form, it's more of a handle to something.
Yeah, I know, but it's a globally understood handle.
Yes, yes.
So in terms of what we save, it's sufficient to save the handle, correct?
No.
Why not?
I mean, if you create something, you get a completely new handle that only exists until you quit. If you want that, you need...
Okay, but that's what's not going to work. Okay, so because the thing, okay, that's not going to work. It has to be the case that the thing you have in this session is serializable, right? So what you're saying is that is a handle to a shared memory space between the Wolfram Language process and a SystemModeler process. Is that correct? And SystemModeler kernel of some kind.
Yes.
Right. So, okay. So what I'm saying is that there has to be some way. So I mean, we've had this issue with in other places, right? In audio and things like this. This is a case. Okay. So Roger, you get what the issue is here. I mean, the point is, it has to be the case that the thing that is in the input form is. Let me show you a completely horrendous example that is about to get fixed. Okay, of a really bad case of something like this. Okay, so if I say autocomplete of, I don't know, random sample of word list, comma 20 or something like this. Okay, I will get something completely horrendous. Look at this is absolutely horrifying. What happens here? Okay, see that?
Right.
Okay, so how is that going to get fixed? The answer is that's going to get fixed by actually including that this list in the auto-completion function, so that upon serialization, it can be reconstructed. You get what I'm saying? So this is there as a cache, pointer when the thing is actually live, just like you will have essentially a cache pointer to the shared memory space the shared system model and memory space.
Okay,
but
so
what you don't want to do, yeah, go ahead.
Then if you want that, the electric circuit is not a freestanding thing. It also needs the hierarchy of introductory examples and component based, which are packages which contain the electric circuit and also other stuff. So in that case, you basically need to have all of introductory examples in every single.
Wait. No, we don't. No, we don't. Because it's just like if you reference something in the data repository, for example, you don't need to import everything from the data repository. It has a canonical, reference. It has a canonical, UUID, URL, whatever you want to call it, right? URI.
Yeah, but those are independent of each other.
No, but what you're saying is if you create
no, but
you build your own electric circuit.
If I create an electric circuit, it's probably going to be pretty freestanding. But if I create a package with 10 electric circuits that build on each other, then it doesn't make sense to save one of them.
No, I agree. But what I'm saying is you will save everything that is your construction and the things that are part of the Modelica standard library and so on. You don't have to resave because those things are available globally to everybody.
Right.
Right. So what I'm saying is the stuff that is your custom build that isn't part of, the standardly available stuff is, it's just like you don't need to go down inside a Wolfram Language function and save the internal code of that function because it's available to anybody.
Yeah, sure.
So
but
what I'm suggesting here, yeah, go ahead.
Even the stuff you build yourself is going to be a whole hierarchy of stuff at some point.
Fine. But where is that? So that hierarchy is represented right now in something that can be turned into a Wolfram Language expression, but usually doesn't live that way because it's living inside the shared memory. Is that correct?
Right. Or actually multiple. The whole different pieces of the hierarchy can be turned into these system models. So for example, the electric circuit here, you have, that is one system model, but you can also have introductory examples component based. That's also a valid system model.
That's fine. But what I'm saying is so what you're saying is the save system model thing what will that save it as? What will it look like? How do I get?
It will save it as a .mo file, which is Modelica code, plain text.
Wow. Okay. So I saw that there's a way of getting a Modelica string. So if I take this system model here.
Yeah, that's what's going to be saved.
Okay, so if I take that and I say of this Modelica string, right? Okay, so that's some kind of Modelica specification. Okay.
Right.
So what I'm saying is that in that system model here, if you build your own system model, then what I'm asking for is that the Modelica string or something equivalent to it be actually available in that system model as something which, were you to look at the expression, you would see that Modelica string. Now, in its representation in an actual running session, right, that string just needs to be it's a pointer to that piece of shared memory. Does that string exist in the shared memory?
Not as a string. It's a syntax tree, basically, an abstract syntax tree.
Okay, well, fine. But then what has to happen is that were you to actually ask for part such and such, so I don't exactly know what the right way to do this is, but roughly what has to happen is, let's see, how do we make an indirect expression that works that way? So you get what I'm saying. So that if you were to look at system model, if you were to do an input form on it, you would basically see that string. Because if you can do that, then all of the saving stuff will just happen automatically.
I mean,
the system model wrapper. Go ahead.
The Modelica language has additional restrictions of how you're allowed to save stuff in MO files. You can't just put them in any MO file.
I don't care. It doesn't matter. It doesn't make any difference. What I'm saying is, if system model, the function, contains something where it is able to eat not just these names, right, like component-based electric circuit, but also Modelica strings, right? It clearly can eat Modelica strings because that's what it's doing when you load from a file, right?
Yes.
So if one of its arguments effectively, or something in its structure, is a Modelica string, it should be able to reconstitute that live Modelica construct, right?
Not all of it. I mean, if you only had this string, you couldn't necessarily reconstruct your model.
No, but listen. There are dependencies, right? Some of those dependencies are on a standard library. Those are underneath. Then there are dependencies that are on things you've built, which, you've got to have. Otherwise, obviously, you can't reconstruct it.
Yes. But
right. So what I'm saying is, yeah.
Those dependencies, if you put those in a hierarchy, which you are encouraged to do for organizational reasons, I mean, it's going to be easier to find and stuff.
Right. So most likely what you would end up with is an association which says this would be the, this is the something like, let's just imagine Modelica data, arrow, whatever. And then, let's imagine that what's inside SystemModel is, model name or something, model, I don't know, canonical name or whatever you call it, I don't know, which is, and that's the whole, if there is just a single name, it's probably just that. Or instead it would be something like, I'm making this up because I'm not quite sure what the right way to do this is, but something like main, arrow, whatever. That's the top level thing that is what this system model is going to be, together with, oh, don't tell me my keyboard, no, it didn't. System model there, together with the subdependencies, whatever they're named. See what I'm saying? Each one of those is its own Modelica string. So it's as if you had those separate files. Am I making sense?
But how would you then, okay, so in the example for the electric circuit here, you could then represent introductory examples, the package, but how do you represent further down?
Well, look, whatever you need to represent, you have a whole directory here. You have a whole hierarchy. You can represent whatever you need to represent. You have Modelica strings, which would be, however these are represented normally, you are simply representing that file system as an association, just like you do in the way file system map works. Right, so file system map can give you the contents of files in an association where the names of the files are given by the keys in the association. So I'm suggesting doing the same thing here. And what's the purpose of this? The purpose of this is that then you don't need all these functions like save system model, because what you would have then is that simply an export to Modelica, if that's what you want, of this system model. Right? But in all cases, what you end up having in the system model object, the system model expression is a self-contained thing.
I mean, we can still have export to Modelica, I guess, without.
I understand, but without this. But I'm saying that this is a principle that we need to follow. That whenever you have an expression, like you could see that example for the auto-completion function was totally stupid. Right? You understand that was stupid, because if you save the notebook, you save the expression, you're dead meat. You can't reconstruct anything, right?
Right.
So we want to avoid that. I mean, clearly there are some cases where there's no choice, like a file pointer or something, an open file in a session where there's a random file pointer pointing into La La Land. That doesn't work. If it was a pointer to something in the cloud where there's a UUID, then it does work, right? I need to disappear in a moment here.
Yeah,
but
I can see if I can come up with the way that works with Modelica. I'm not sure it's going to be possible, but
but I mean, this is what I think we should aim for, is something where what you see in the system model is kind of a
right. I mean,
what am I trying to say?
There's the additional complication that if you modify something in the graphical environment, it's not going to modify this side.
Well, let's think about that. Look, the right thing to do is that system model is somehow lazy, okay? And that by the time you're serializing to the point of saying input form, it's going to resolve the laziness. Get what I'm saying? but it doesn't necessarily have to resolve the laziness. I mean, there are plenty of colon equals variables whose values do not resolve until you're actually going to save them. Do you get what I'm saying?
Right. Right.
And that's what I think should happen here. That is that the thing should be, you know, you have a system model, it's got its name, it's got its picture, et cetera, et cetera, et cetera. That can be lazily derived from the shared memory.
Right.
But upon serialization, now the question is, what do you save in the notebook in that case? Go ahead.
Yeah, exactly. If it only serializes on input form, it's never gonna.
Well, then worst case is it invalidates. I mean, worst case is you save what you can, and it simply says it invalidates the thing, which in some civilized way, just like it would have to invalidate a file pointer.
Right. So in that case, it will also invalidate if you modify it in the graphical interface.
Probably. It will invalidate.
Update to the newest state at that point.
I unfortunately have to go, so
yeah.
We can continue this, and for those who've been watching this live stream, how does they say it? Next, it's not quite stay tuned. We're not doing an ad break. We're stopping here. There'll be another episode where we find out what happens with the exciting life and times of SystemModel.